Welcome to today's video. We are going to be solving matrices today, and we are going to be solving 2016 papers, 2017 papers and 2018 papers. I do trust and hope that you will watch this video to the end so that together we can do a revision on the matrix questions which we had in these three papers that I have just mentioned. So number one, we are going to start with the 2016 mathematics paper, internal paper 2016. Question 1a reads, given that matrix Q is equal to 3, negative 2, x and 4 as shown on the screen here, find 1, the value of x given that the determinant of matrix Q is 2. So our solution, you are going to clearly indicate you're dealing with question 1a, but the first part of the question. Now, maybe let's begin by us having the matrix. So we've been told Q is equal to this matrix. Matrix Q is equal to this matrix, and therefore we're supposed to find the value of x. The value of x given that the determinant of Q is 2. So one thing that we know is determinant is equal to the major diagonal minus the minor diagonal, which is equal to, so our major diagonal is this one. So the major diagonal being 3 by 4 minus our minor diagonal being this one, x times negative 2, in that way. And our determinant, we've been told it's 2. So we come, determinant there 2, then we have 12 there, and we have x times negative 2, it gives us negative 2x. When we come here, our 2 there is equal to 12, negative times the negative, that gives this a positive, makes this a positive. Having done that, we now have to take these two to the other side. We're taking the 12 to the other side. Why are we taking it to the other side? We're trying to group the like terms. So if we move 2 to the other side, we have 2 minus 12 being equal to 2x. That gives us negative 10 being equal to 2x. We say over 2, that gives us a negative 5, and that gives us x alone. So we are saying negative 5 is equal to x, which is the same as x is equal to negative 5. Good. You do that, you are done. We go to our second part of the question. The second part says, find the inverse of matrix Q. Find the inverse of matrix Q. So we indicate our question there. Now we are dealing with the second part, and we are looking for the inverse of matrix Q. Now, the inverse is going to be shown in that way, being equal to 1 over the determinant, and we've been told that the determinant of this is 2. Open brackets. We have our 3 there. Now what happens when filling in there? Numbers in the major diagonal, they swap. So if 3 was on top there, the 3 will go down. Then the 4 which was down goes up. Then you multiply all the numbers in the minor diagonal with a negative. So negative times 2 there, you get a positive 2, and then that gives you a negative x. And you close in that way. So we make a replacement now. 1 over 2, open bracket, you have your 4, you have your 2, and you have your negative x. However, on the negative x, we have been told in our question that we just calculated, what we found was that the value of x is negative 5. So we replace x with its value, which is negative 5. And if we do that, you have negative, open bracket. This negative is the negative, that one which is on x. However, x on its own also has another negative 5 inside there. And then we have 3. So if it's to write the answer now, we would say 1 over 2, open bracket, 4, 5, 2, 3. So this would be our Q inverse. This could be our Q inverse. And also, you can even take it further. You can even take it further by multiplying the fraction outside with the numbers that are inside. And if we do that, if we don't end here, meaning we can take it further and we can conclude on this part. 1 over 2 times 4, it gives us a 2. 1 over 2 times 5, it gives us a 5 over 2. 1 over 2 times 2, it gives us a 1. And 1 over 2 times 3, it gives us a 3 over 2. That way, it is also acceptable. Okay, now we move on to our second question. Our second question, in that, we'll be looking at now the 2016 GCE paper. 2016 GCE paper 2 matrix question. It came under question 2C, and I'll read it. Given that the determinant of matrix A is equal to x minus 2, as we're able to see there on the screen, x, 2, and 1. The determinant of that matrix is 4. Question 1. Find the value of x. So just go ahead and write the matrix that we are putting into consideration. Our matrix is matrix A is x minus 2, 2, x, 1. Question 1 says, okay, maybe we can write it in this way, 2C, or numbering 2C, then part 1 in that way. Find the value of x. So like we know, first things first, we can have a formula there. We're saying determinant is equal to the major diagonal minus the minor diagonal. That gives us our determinant. So we've been told that the determinant is 4 equal to our major diagonal is this one here. That represents our major diagonal. So that's our major diagonal over there in that way. Or probably I should use a different kind of pen, a different color, to indicate that's our major diagonal. So our major diagonal, we put in brackets there, we are saying 1 multiplied by x minus 2. Take away our minor diagonal. So our minor diagonal is this one right here. So our minor diagonal is 2 multiplied by x. So 4 is equal to 1 times x, it's x, 1 times negative 2, then minus 2 times x, we have 2x. Having reached that point, what we do is that we are going to group the like terms. And so we have our 4 being equal to the like terms there, x minus 2x minus 2. So 4 is equal to negative x. 4 is equal to negative x minus 2. We do that, we group the like terms. We take the negative 2 to the other side. So if we do that, it becomes 4 plus 2 being equal to negative x. Add 4 plus 2, it gives us 6 being equal to negative x. Being equal to negative x. So we do over negative 1 over negative 1. Negative 1 cancels that negative. Why are we doing over negative 1? Because we're looking for the value of x and not the value of negative x. So we also do the same there, and it gives us negative 6 is equal to x, which is also written as x is equal to negative 6. We go to our second part of the question. Our second part of the question, our part 2 of the same question. It says, write the inverse of matrix A. Write the inverse of matrix A. So our matrix which we are looking at is A. So you indicate your inverse there. You remember that the formula should be 1 over determinant, open brackets, then you swap values in the major diagonal. So we're looking at, this was x minus 2 in the original question, so that becomes 1, and the x minus 2 goes at the bottom. That's our major diagonal. Then we multiply the minor diagonal with a negative, so that was a positive 2, it becomes a negative 2, and that becomes the negative x in that way. So let's just replace that with the values that we already know. So it's 1 over 4, that's our determinant. Open brackets, 1, negative 2. The value of x is negative 6. Now, negative 6, there is negative x, so negative, this is that negative on x, open bracket. X has a negative also, it's in that way. And then you do the same there. That's negative 6 minus 2, open brackets, which will be equal to 1 over 4, open brackets, 1, negative 2, negative times negative, that's a positive 6, and we have a negative 8. If you do that, you are able to acquire some marks there. However, you can still take it to the very end. You take it to the very end, so you can either end there, or maybe we take it to the very end. You can do open bracket, 1 over 4 times 1, 1 over 4 times 6, 1 over 4 times negative 2, and 1 over 4 times negative 8, making the final answer to be 1 over 4 and negative 1 over 4. Then there we get a 3 over 2. Pardon me, on this one, this should be a 1 over 2. This should be a 1 over 2. Our space is running out, so bear with me. That should be a 1 over 2. And then lastly, when we multiply that, we multiply this one, 1 over 4 times 8, we are getting 2, negative 2. In that way. If you do that, you would have finished completely. (2017) Matrices, Paper 2, Internal, Question 1A. Given that matrix M is equal to 3, 5, negative 2x. Find the value of x for which the determinant is 22. Find the value of x for which the determinant is 22. So part 1 of this question of finding the value. So as usual, you know that that is the major diagonal, then this is the minor diagonal. So we start, okay, our dit is equal to major diagonal minus our minor diagonal, and we've been told the determinant is 22, which will be equal to multiply the values in the major diagonal minus values in the minor diagonal. So there your 22 is maintained, equal to 3x minus negative 10. So 22 is equal to 3x plus 10. Take this 10 to the other side. So looking at 22 minus 10 being equal to 3x. Subtract that, you have 12 being equal to 3x over 3 over 3, you get 4 there being equal to x alone there. That can also be written as x is equal to 4, so that is the value of x. We quickly go and answer part 2 of this same question. Part 2 of this same question, and the question says, hence find the inverse of m. So we are looking for m inverse, which is equal to 1 over the determinant, open bracket, swap values in the major diagonal, so you have your x there, your 3, then multiply the minor diagonal by a negative, so you have negative 5 and a positive 2 right there. Okay, that being the case, we continue. Equals 1, our determinant have said it's 22, over the value of x, 4, negative 5, 2, and 3. Right. So that's okay. like that. However, we can also complete it in this way. You can just simply multiply 22 by 4 by negative 5 by 2 by 3, and you come to get your final. Okay, the other way you can write it, you can conclude it, you can say 4 there, or pardon me, 2 into that, because there 2 times, 2 there 11, 2 there 1, 2 there 11. Then those ones remain just like that, so you have 2 over 11 negative 5 over 22. You have a 1 over 11 and you have a 3 over 22. You can also end it there. Then we are done. Having answered like that, that's how we do it. So quickly, let's now go and answer the 2017 GCE paper. At now 2017 paper 2 GCE, and that was question 1A as well. Question 1A. So the question reads, given that matrix K is equal to 10, negative 2, 11, negative 2, comma. Question 1, find the determinant of K. Find the determinant of K. So we're looking at 1A, then part 1. Finding the determinant, we know that determinant is equal to major diagonal times the minor diagonal, which is going to be equal to, so that's our major diagonal there. So 10 multiplied by negative 2 minus, pardon me, that should be a minus our minor diagonal being that one, 11 by negative 2, and we get negative 20 minus negative 22 close, which is equal to negative 20 plus 22, which is equal to 2 as our determinant. Part B of that question says find the inverse of K. So second part is talking about finding the inverse of matrix K. As we know, we're going to say K inverse is equal to 1 over the determinant. We swap like usual, so that becomes negative 2, 10, then multiply the minor diagonal with a negative, that becomes a 2 and a negative 11 in that way. So we're saying 1 over 2, open brackets, negative 2, 2, 11, 10. So that is okay right there. However, if you like, you can also now complete it to the very end, where you can say 1 over 2 times negative 2, 1 over 2 times 2, 1 over 2 times negative 11, 1 over 2 times 10. And this will give you it will take you to the end. There 1, there 1. When you multiply, you find yourself with negative 1. This is maintained as negative 11 over 2. The other side, 2 there 1, 2 there 1, so you have a 1, and then you have 2 there 1, 2 there 5, and you have a 5 there. can end it that way. Alright, thank you very much for following through up to the end of our 2017 paper 2 matrix question. So now let's do our last part for today's video dealing with matrices. We are going to solve the matrices 2018 paper 2 internal question 1A, and the question reads, given that matrix A is equal to, given that matrix A is equal to 4, -5, 1, 2, and matrix B, is equal to 8, Y, 3, 5. Question 1. Find the value of Y for which the determinant of A and B are equal. So let's begin. We indicate our 1A, part 1. Find the value of Y given that the determinant of A and B are equal. So first things first there, what we are going to do is that we are going to find the determinant of matrix A. Since both matrices A and B have the same determinant, we begin by finding the determinant of matrix A, then we are going to apply that determinant to matrix B. So we'll start, we are finding the determinant of matrix A first. So as we know, that's our major diagonal, and that is our minor diagonal. So we are going to indicate determinant A is equal to 4 times 2 minus -5 times 1, which is equal to 8 minus -5, which is equal to 8, plus 5, which is equal to 13. So the determinant of A is 13. So what next? Now that we found the determinant of A, we apply it on matrix B. They've said that whatever determinant is for A is the same determinant for matrix B. So to find the value of Y, we follow that same formula. Now we say determinant B is equal to, as we know, major diagonal minus the minor diagonal. So in this case, major diagonal is 8 times 5 minus the minor diagonal, which is Y times 3, which will give us, let's remember also to replace the determinant of B with 13 being equal to 8 times 5, 40 minus 3Y. So from at this level we group the like terms. So we have 13 take away 40, 13 take away 40 being equal to negative Y. When we subtract that, we get negative 27 being equal to negative 3Y. To find the value of Y, we say over negative 3 over negative 3. So that cancels, negative cancels, 3 into 27, that's a 9 being equal to Y. So Y is equal to 9. You have that. That's the value of Y. Our second part of the question says, hence find the inverse of B. Hence find the inverse of B. So we're going to do our second part here. Finding the inverse of B. So we do B inverse is equal to 1 over the determinant of B, to be specific, open bracket. We put our 8, 3, Y, 5, and you close in that way. So our B inverse is equal to 1 over the determinant being 13, open bracket, 8, replace y with its value, 9, then you have 3 there, you have 5, however you're not done, we've not swapped, so 1 over 3, open bracket, elements in the major diagonal have to be swapped, so you have 5 and 8 goes down, then multiply the minor diagonal with a negative, so that gives us negative 9 and negative 3 in that way. So when you end there, that's our answer. If you, well, you can even still take it further by multiplying. You can end there, you get the 4 marks, no doubt about it. However, if you like, you can also continue this one. You can multiply 1 over 3 times 5. It will give you 5 over that. 1 over 3 times negative 9, it will give you negative 9 over 1 over 3. 1 over 3 times that, it will give you 3 over 1 over 3 in that way. 8, 1 over 3, 1 over 13 times that, it will give you 8 over 1 over 3. Done. That can also be your conclusion. We now move on to go to 2018 paper 2 GCE matrix question that came. 2018 GCE matrix question that came. I'll write our heading there. Heading, we're looking at 2018 paper 2 GCE, and it came as question number 1A. Let's begin to solve. Given that matrix A is equal to 2x, 2, 3x. Question 1. Find the positive value of x for which the determinant is 12. Find the positive value of x for which the determinant is 12. So there, we tell them, okay, don't forget the numbering. That's 1A, and the question 1A, part 1. So I'm going to say determinant A is equal to major diagonal minus minor diagonal, which is equal to 2x by x minus 3 times 2, that gives us 2x squared minus 6. 2x squared minus 6. 2x squared minus 6, but we should remember that in the question we have been given that the determinant is 12. So the determinant is 12 there. So what we do, we have our 12 being equal to that. Okay. Don't do it the way I've done it. As you can see, I have literally repeated the same step over. So you can just skip one step, just do it once. However, the next step, what we're supposed to do there is 12 is equal to group the like terms rather. So when you have that send the 6 to the other side, it becomes so what we are looking for there is the value of x and not the value of x squared. So to eliminate the squared, we square root on both sides. So x square root cancels that, and the 9 square root, that's a 3. So you have that. What that means is that the value of x is equal to 3. So when you do that, you would have found the value of x that we are looking for. So let's go to our second question. Our second question, the second part of this question says, hence, otherwise, write A inverse. Hence or otherwise, write A inverse. So we go to our second part. So we say A inverse is equal to, we know it should be that way. Then I think let's do this earlier so we don't take long like we did on the other question. Let's swap the major diagonals in advance. We know we do that. Then 2x over there, multiply the minor diagonal with a negative, so that's negative 2 and that's negative 3, which will be equal to 1 over the determinant. What is the determinant? The question says it's 12. So you have your 12 as the determinant there, over what is the value of x there? The value of x is 3. Then you have your negative 2. Then you have your negative 3. Then you have got 2 times the value of x, which is 3, giving us 6. 6 there. So at this particular point, they'll be able to give you your 4 marks. However, like we've been doing with the rest of the questions, we can even take it further to complete it. So to do that, we multiply now 1 over 12 times 3. You can show it in this way. What happens at 12 there, 4, 3 there, 1, 3 there, 1, 3 there, 4, 2 there, 1, 2 there, 6, 6 there, 1, 6 there, 2. We'll gather this now together, 1 times 1, it's, we change the color of the pen to indicate our final answer. So there is 1 over 4. At the bottom it's 1 times negative 1, you get negative 1 over 4 as well. To the other side you have your 1 over 6, and the other side it is 1 over 2. This can also be one way that you conclude this question. So that was the last question we had to deal with in this video. 2018 paper 2 GCE matrix question 1A. Do watch out for our next video. It will be coming out very soon. Stay blessed. Yeah.